Okay, number 5. This one, we're given the equation in standard form. So we have to do a little extra work to find the vertex. There are several different ways that we can go about doing this. When it's in standard form, one of the things you can do, and this comes from the quadratic formula. Let me actually write that out. X equals negative b plus or minus the square root of b squared minus 4ac, and all of this is divided by 2a, not this part, not the x equal, just this part. And from here, if you focus on the negative b over 2a part, or is it just b over 2a? I'm going to pause for a minute. But you can do the, I think it's negative b over 2a. I'm going blank. You find the x value, and then once you find the x value, you will take this value that you get and then plug it in to the original equation, which they're using r, but just traditional is f of x. They're using r, and then you plug in the negative b over 2a here, and then that will give you that ordered pair. And then you could also, instead of doing this part, you can use a different part of the formula. Let me see, that is still negative b over 2a, and then the other part comes similar from this part right here, but it's backwards. It's going to be 4ac minus b squared all over 4a. Okay, so that's just a different formula. And then we'll do both of them just to verify that we get the same answer as far as order pair. So you take the b value, and when I say b, ax squared plus bx plus c. So you have your x squared term. The number in front of the x squared is your a. The number in front of the single x is b, and the number, the constant term is your c. And so this is what we mean when we say ABC. So I'm going to plug these numbers in and then verify that we get the same answer. So first I'm going to do negative 6 over 2a. So negative 6 over 2a. This is x equals this value. And 2a actually would be a negative 1. Negative 1. I don't want to plug a right there. So we get negative 6 divided by negative 2. And that gives us a positive 3. All right, so now what I'm going to do is I'm going to take 3 and plug it into this equation. R of 3. I have a negative 3 squared plus 6 times 3, and then minus 8. And then so we'll get 9, a negative 9, and then we'll get 6 and 3 give you 18, and then minus 8. 9, so we end up getting a 1. So we're looking at vertex being 3, 1. So that's using this formula. So you do negative b over 2a, comes from the quadratic formula, and then we plug that value in to your equation, and then whatever you get, that's your y value. So 9, yeah. So 3, 1 is what we're getting for our vertex. All right, let's do it with the other formula here. So we've already done this part. So we already know that one value is 3. We don't have to do that again, but we're going to do the 4, and this is the y value. Y equals 4 times -1, and the c value is -8, and then minus b squared, which will be 6 squared, all divided by 4 times a, so 4 times -1. So let's see that we get the same thing. Multiplying all this will give us a -32, actually a -32, and then a positive, it'll turn back. So 8 and 4, 32, but it'll be a negative, times a -1 to give you a positive 32. This will give you a 36. So we have 32 minus 36 all over -4. And again, it looks like we get -4 over -4, and that gives us +1. So yes, we get a 1 here, so we get 3 and 1. So that's how you get the vertex, okay? Both of these formulas are in the textbook. I think we saw them in the Learn section. But there's 2 different ways you can do it. If you don't like plugging it in, you can just use 2 different formulas and you still get the same vertex. So 3, 1 is what we get. All right, so now after we do that, we want to find the x-intercepts. So finding the x-intercepts, we want to either do the quadratic formula, or we can try to see if this problem will factor. I think factoring is going to be the easiest way to do it. So we're going to try to factor this guy. Now, when you factor, you got to make sure your leading term is positive. So this is negative, and it will not work when it's negative. So to fix that, we're going to multiply everything by -1. So that will give us a positive x squared. Or you can look at it as factoring out a -1 if you want to. It won't change anything on the outside. This will give us a -6x and a +8. And we set this equal to 0. So now that the leading term is positive, we're going to multiply our leading term, which is 1, times the constant term, which is 8. We're going to factor 8, 1 and 8, 2 and 4. Whatever your second sign is, which is positive, we want to add the factors to get the middle number. So if I add 1 and 7, that will give me 9. That's not it. 2 and 4 will give me 6. So these are the ones I use. That means it will factor. So bring down, I'm going to leave that -1 on the outside, and then 2 sets of parentheses. Separate the x squared, so x here and x here. The numbers we found will go at the back, so 2 and 4. And then you got to figure out the sign. So going left to right inside, negative is your first sign. So your first sign is your bigger number. Okay, so the first sign tells you your bigger number. So bigger number meaning the 2 we added in. So because of that's negative, I will put a negative here on my bigger number. And the second sign, positive means same, and negative means different. So since this is positive, that means these are going to have the same sign. Now, if that is kind of confusing, you can kind of use a little math intuition and kind of figure out what do I need these signs to be so that these add to be a -6. And then you can figure out both negative. All right, then from here, we just set them both equal to 0. And then, so I have x minus 2 equals 0 and x minus 4 equals 0. Add 2, x equals 2, add 4, x equals 4, and we get our 2 x-intercepts. So we get 2 x-intercepts, and those are 2, 0, and 4, 0. And then we want to find 2 points. So again, I'm going to do the same thing. We have our vertex here. I'm going to pick one point either to the left or to the right of the vertex and then solve it. Now we can plug it in or we can do synthetic division. I will show you both. We're going to need to learn synthetic division later on. But for right now, I'm going to show you both of them, and you can use whichever one you like. So I'm going to pick 2, the number to the left. So the numbers I'm going to be using, x equals 2 and 4. They're on either side of the 3. And I'm going to plug in 2. So I'm going to do r of 2. And then that's going to be a negative 2 squared. So the 2 in parentheses, the negative on the outside. And then plus 6 times 2. And then minus 8. So that's from our original equation. This one right here. That's what I'm looking at. All right, so we're going to simplify. 2 squared is 4, but it's going to be a negative. 6 times 2 is 12, and then minus 8. This will give us 0. I guess I wasn't thinking. 2 was one of the x-intercepts, so 2 and 4 are not going to help us. I need to use a different number. So let's use, let's go 2 to the left. So let's use 1. 1. So since I went 2 to the left, I'm going to go 2 to the right. So 1 and 5. I was not paying attention to that, sorry. X, 1, and 5. We're going to use 1 and 5. All right, so let's try this again. R of 1, negative 1 squared plus 6 times 1 minus 8. So we get 1, a negative 1, plus 6, minus 8. And this will give us a negative 3. So our 2 ordered pairs would be 1, negative 3, and then 5, negative 3. Okay, so these will be our ordered pairs. Now, with synthetic division, I like that one because you don't have to do, as much computation. I think it's a little bit easier. So what we do is we take the coefficients of our parabola. So negative 1, 6, and negative 8. Negative 1, 6, and negative 8. Now there's a little bit more to picking these coefficients. You have to make sure you have all your terms. And when I say terms, it means this is a second degree, this is a first degree, and this would be considered as x to the 0. Everything has to be in order. You have to have 2, 1, 0, or whatever your biggest number is, you got to count down in order to 0. If you have all your terms, then you can list your constants. Now, the number that I said I was going to use was 1. Now, I will go ahead and use 5 this time just to show you that we still get negative 3. So I'm going to put a 5 here. I'll call that my box number. And I'm going to draw a line. You bring your first term straight down, negative 1. And then you multiply below the line. So 5 times negative 1 is negative 5. You write the result up here. And then you add or subtract, which that will give us 1. And then you repeat. 5 times 1 is 5. Write the result up there. And then add or subtract. And that will give us negative 3. So whatever you end up with, that is your value that you would get if you were to plug it in. So I plugged in negative 1 here, sorry, not negative 1, positive 1 here, and got negative 3. And then I also did the same thing, but I used synthetic, and I used a 5, and the 5 gave us negative 3 as well. So x5 and negative 3, and then you can also see the 1 and negative 3 here. So that would be our 2 other points. So 1, negative 3, and 5, negative 3, negative 3. There we go. Alrighty. And lastly, we're going to graph it. So our vertex, don't see it, was 3, 1 here. So we're going to go right 3 and up 1. And then we're going to just plot let's do the intercepts. Let's go 2, 0. So that'll just drop straight down. A little bit too low. 2, 0. And that'll give us 4, 0. That looks good. And we can submit.